Welcome to Calculus Conqueror Introduction to Limits Part 2, Solving Limits by Simplifying Complex Fractions. In the last video, we took a look at the function g of x equals x squared minus 1 divided by x minus 1 and saw that g of 1 does not exist. But the limit of g of x as x approaches 1 does exist and equals 2. We determine this by factoring g of x and canceling like terms. So we took our function g of x, we took the limit of it, which is x squared minus 1 divided by x minus 1 as x approaches 1, and we factored that into x plus 1 times x minus 1 divided by x minus 1. We canceled the like terms, and we plugged in 1 for x, and we got 1 plus 1 equals 2. In general, we can solve limits algebraically through three procedures. The first is factoring and canceling like terms, just as we did in the first video. The second is simplifying complex fractions by getting common denominators, then combining and adding like terms, which is what we will be doing in this video. And the third is conjugating expressions containing radicals. We'll be doing that in the next video. So let's start with the function f of x equals 1 over x plus 1 divided by x plus 1. Well, we can see right away that there is the fraction 1 over x within the larger fraction. What is the limit of this function as x approaches negative 1? The first step for solving limits is to simply plug the number that x is approaching, plug that number in. If you get a real number, then you're done. If not, meaning that you get 0 over 0, which is a whole, or 0 in the denominator, which is a vertical asymptote, then you'll need to do some sort of algebraic shapeshifting. So let's go ahead and plug that in. So we plug in negative 1 for x, and we end up getting 0 over 0, which is a whole. Since there is a hole in the graph at x equals 1, we now need to do some algebraic manipulating. So we start with the limit of our function, that is the limit of 1 over x plus 1 divided by x plus 1 as x is approaching negative 1. And we get a common denominator in the numerator. So we have 1 over x plus x over x, all over x plus 1. With the two fractions with the common denominator in the numerator, we join those together to get 1 plus x over x. And the denominator of x plus 1, we turn that into a fraction, being x plus 1 over 1. We learned long ago that when you have a fraction divided by a fraction, you multiply by the reciprocal. And that's what we are doing here. We're taking the reciprocal of the denominator and actually placing it on top of itself in both the numerator and the denominator. And all that turns out to be is a fancy form of 1, but it's very helpful because so many things cancel out here. Nearly everything cancels out except for a 1 over x. So we're left with the limit of 1 over x as x approaches negative 1. We plug the negative 1 in for x, and we have 1 over negative 1, and that is equal to negative 1. Therefore, the limit of 1 over x plus 1 divided by x plus 1 as x approaches negative 1 equals negative 1. I hope this helps, and thank you very much. Have a great day.